Hi, Dave here. Today I have a tour of a couple of very interesting telescope mounts. On my right and your left, you'll see a mount for a 4-inch Unitron refractor with the clock drive. This is the electric clock drive, and it's running right now. You can't tell probably, but it's working. And in addition to that, I have this very interesting mount that I was able to buy on eBay recently, and it is very similar to the Unitron 4-inch. It turns out that, at least from my best appraisal, it is not a Unitron, although it is very similar to a Unitron. In some respects, it is not quite as good. In other respects, it is, in fact, superior to a Unitron. It appears to be a home-built mount made by an expert maker. Whoever made this telescope mount really knew what they were doing. They're a fine machinist. I'm an amateur machinist myself, and I appreciate fine work. This one is clearly done by someone who really knew what they were doing. These two mounts are both running right now, and I wanted to point out a couple of the differences between the two mounts. The Unitron mount has a clock drive right here. The clock drive is slowly causing the worm gear and the worm wheel to turn, tracking at a sidereal rate of approximately 1 revolution per day. This is similar, but it's different. I believe this is home built, home designed. I've never seen any other commercial telescope of this size that was designed with these kinds of features. The motor here that's driving the telescope is a 15 RPM motor. You might be able to see it, and I'll show you some close-ups. This thing is actually turning pretty rapidly. In the case of the Unitron, this whole thing is turning very slowly. The gear work is all inside the box here, and this is turning very slowly, driving the worm wheel. Well, the interesting thing about this is that with a Unitron 4-inch telescope, the way you would the way you would adjust the slow motion, if you were tracking a star, doing an astrophotograph perhaps, the way you would do that would be using, in the day, they would have used this device here. Now this slowly moves the telescope in right ascension. Unfortunately, it's a mechanical contraction, so it's attached to the telescope. If you're taking a photograph with a long focal ratio telescope, and you make even the slightest motion, the slightest tweak, the slightest jiggle, you're going to cause a problem with the astrophotograph as a result. Nowadays it's all done with electronics, and you would change the rate of the turning of the motor here with what's called a drive corrector. So that would all be done electronically today. Back in the day they didn't have such devices, so you would have done the corrections manually. Well, this device is a little bit different, because what's happening here is, and I'll show you a close-up of this, the drive is turning at a fairly substantial rate here. It's reduced up here by the time it gets to that, and I'll show you a close-up. And what happens here is you can change the rate. You actually don't change the rate, but you're actually adding a tracking on top of the tracking by turning this device. It's got a very beautiful set of gears inside here, differential gear system, that allows you to change the rate at which this is turning by adding your own slight tweak here and slight tweak there. This is ideal. This would have been a very nice mechanical way of tracking, doing astrophotography. There are several other things about this mount that make me think it is not Unitron. First of all, although the castings are beautiful and everything on the thing is beautiful, it is not quite the same. For example, this setting circle is almost exactly the same size as that setting circle. It has a very nice vernier on it. This setting circle here is actually bigger than the setting circle on the Unitron. And it's calibrated in a slightly odd way. It's very functional, very usable. You could actually use this under the night sky. But it's slightly different, and it's also bigger. That makes it more precise. The Unitron is a 3.5-inch circle and this is about a 4.5-inch circle, so it's more precise. All the gear work and so forth is, as far as I can tell, American thread. So this was made in the United States. So some of these characteristics give this away as American-made, home-built, although extremely well made. I am a big fan of whoever made this scope. It was made by somebody in their own machine shop, perhaps. I'm going to show you some close-ups now. So I'll show you a close-up of this thing actually working. Okay, this is a close-up of the clock drive, and I think you can see it turning fairly rapidly. But watch what happens when I engage this. When I engage this, I can turn it and make it actually, if I turn it fast enough, I can actually stop it, maybe even reverse it. I can certainly slow it down quite a bit, and you can tell perhaps that I can make it go faster. Now the changes you would want to make to this rate would be very slight, so I'm overdoing this by quite a bit. No one would ever do that. You'd probably be making very slight corrections like that, maybe, to make sure that your star was dead on and tracking perfectly. The mechanical device inside here is quite interesting, so I'm going to show you a close-up of that also. Okay, I've decoupled this from the telescope and I wanted to show you the interior of this. The maker of this device encased this in plastic. There's a little plastic screen on here, and the reason for that was to show off the innards here. I'm not sure if I'll be able to make a video that will show it quite adequately, but you can see there's a nice beautiful set of gears inside there, and you can also see what happens when I turn this. What I do is I slightly move the entire sort of gear housing, and I change the rate by doing that. I think you can see this is quite lovely, quite well made, beautiful. I'm not sure if he made all these gears. I think it's quite possible that he actually cut all these gears, actually hobbed the worm gears and so forth. It's unbelievable how good a craftsman this fellow was. So this is a thing of beauty, absolutely gorgeous. Not Unitron, but in fact, I think in this case we have something that is superior to Unitron. This is the Unitron 4-inch clock drive in operation. I think you can hear the noise it's making. Clearly there's a motor inside there and a lot of gears turning. And you may be able to, I doubt it, you might be able to see a slight bit of motion. This thing is actually turning. And of course I don't have it tightened down. I don't want to cause any stress on the equipment here. But this is slowly turning. That turns this. This is called the worm gear. And then this up here is called the worm wheel. So that all turns very, very slowly to compensate for the motion of the Earth. I hope you have enjoyed my little tour of this Unitron 4-inch telescope mount and this clone of a Unitron 4-inch telescope mount with many improvements. Thank you very much.